So we're going to get into area of all different types of two-dimensional shapes. Before we begin though, I highly recommend either using a sheet of paper in your notebook or a piece of computer paper or something and put all of our area formulas in the same location, and then that way when you need the area formulas you can find them all in one place. Okay, it's just a recommendation, just saying. I'm only the teacher, right? Okay. So, first thing that we're starting with is areas of parallelograms. Now, I want you to write down A, and of course that means area. Okay? So we have for a parallelogram that A equals B times H. Now, this B means base, and H means height. The really important information about this though is that height is in terms of the altitude. Okay, so remember we talked about altitude, that it was a 90-degree angle. So when we say height, we're not talking about this side over here. That is not the height. We're talking about straight up and down. So if I were to tell you that this is 30 inches right here and the side over here is 10 inches, I want to know the area. Oh, and this is a 60-degree angle down here. Make this 60. Okay? And if I want the area of this, we have to know, first off, the height. Well, we want to draw in from one vertex straight down so that it is perpendicular. Okay, so we make a right angle right here. And now we have one of our special right triangles, a 30, 60, 90. So remember, in a 30, 60, 90, let me draw that out for you real quick. The 60 is the x side, the hypotenuse is 2x, and next to the 30 is x root 3. So this is our 2x side, which means this is our x side. So that means this part is 5. And then this would be our x root 3 side. So this part is 5 root 3. And of course, inches. Okay? So now we're looking for our area. Well, our base. We're measuring the height from the top to the bottom, so we would consider those our bases. So we have the area is, let me erase some of this stuff so we have some room. The base, which we'll say is 30, so area equals base times the height, which is 5 root 3. Remember, you only multiply the numbers on the outside, so this is 150 times the square root of 3. Area is always squared units, so inches squared. The reason it's squared is because it's two-dimensional. Okay? When you get into volume, it is three-dimensional, so because it's just cubed. So we have the area is 150 root 3 inches squared. You can multiply this out if you want, but I don't think that that's totally necessary. I would just leave it. Alright, now moving on to our next couple examples, areas of triangles, trapezoids, and rhombi. So starting with a triangle, the area for a triangle is 1/2 base times the height. And the reason we know that is because a square is base times height, and a triangle is half of that. Now again, for your height, this is talking about the altitude. Okay, now this is really easy to get tricked with because some people will see that this down here is 7.4 centimeters, let's say, and then this one over here is 3.6 centimeters. And they'll think, oh, well then it's just 1/2 times the base, 7.4, times the height, 3.6. No, 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 no. Don't do that. Alright? We're talking about the height of the figure. In most cases it will be given to you. In some cases it won't be given to you. So let's say we know that this is a 32-degree angle. Well, it's not a special right triangle, so we draw in our height. Okay, we draw that in. It's not a special right triangle. However, we can use sine, cosine, and tangent to find out our measurements. So if we're looking for our height, we have the opposite side So opposite and then the hypotenuse, which means we're using sine. So sine of 32 equals opposite divided by the hypotenuse. So multiply both sides by your 3.6 to get 3.6 times the sine of 32, and that will give you your height. So let me just do that real quick, times the sine of 32, and we get 1, so x is about 1.91. Okay, I rounded it to that, so that's close enough. So this height is 1.91 centimeters. So to do our area, we have 1/2. The base means from where? Where did we measure to? We measured from this vertex down to this side, so this side would be considered our base. So 7.4 times the height, aka altitude, which is 1.91. Alright, remember we're doing area, so we have our centimeters squared, so we multiply by 1/2 times 7.4 times 1.91, and we get around 7.06 centimeters squared. There is your area of a triangle. Now if it's a right triangle, it'd be super easy because it's just finding the height is already given to you because it's the altitude. It's a right angle. Your other option, of course, would be to find the area of one triangle and area of the other one and then add them together, but you don't really have a whole lot of information over here, and it's probably a lot of extra work to go around doing that. Okay, now with trapezoids. In a trapezoid, we have our area. Okay, so this one is trapezoids, equals, we have 1/2. We add our bases together, base 1 plus base 2, and multiply by the height. Now, the important part about these right here is these are the parallel sides. Okay, whichever sides are indicated as your parallel sides. In this case, it would be top and bottom. Okay, so if I were to tell you that this top base was 16.5 feet, and I tell you the bottom base is, let's say, 21 feet, and I guess I'll give you the height this time. I'll get you off the sine cosine tangent. You lucky ducks. I'll give you the height. And remember height, again, altitude. Okay, so 90-degree angle right here. Bam. Let's say this is 6 feet. Well, finding the area. 1/2. Add your two bases together, 16.5 plus 21. And then multiply by the height, which is 6. So when we do that, we end up with, I'm almost there, 112. The area is 112.5 feet squared. Always, always, always remember your units. It's super, super, super important. Okay, so don't forget the units. It's always very important. I promise you. All right, now our last one, and then we're done. See, this is so easy, right? Yep. Okay, rhombi. Area. Well, area for a rhombus is basically the same as just a parallelogram, and we know that a rhombus is a parallelogram. So the one difference, though, is let's say I'm only told that this is 4 millimeters. Well, if this is a rhombus, one of the properties of a rhombus is that all 4 sides are congruent, where if it was just a parallelogram, we would have to know this side over here and this one up top. So with it being a rhombus, we've got one of our sides, and we need to know the height. Remember, the height is altitude. I cannot stress this enough. I know I've said it a lot, but I cannot stress it enough. So we're looking for altitude. We're going from one vertex straight down to create a right angle. And now for this we would have to know some kind of information. I'm going to go ahead and make this a 45. Never mind, no I'm not, because that would make it a square, which makes it different. Haha, I'm kidding. I'm going to make that a 30 right there. Something tricky on you. So this one, 4 millimeters over here, which means this one is your X side, which is 2 millimeters, which means this, oh, dang it, I didn't get tricky. Oh well, too bad. Too late to go back. There's no turning back now. The area, base, 4 times height, 2. So area is 8, and then millimeters and squared. Well, bam, well, bam, well, bam. You are just geniuses. Can't you feel it? Well, guess what? We're done. Those are the first 4 types of areas that you're going to learn about. Memorize those. Believe me, your life is going to be easier when you memorize them. But for now, we're done. So let's dance.
This is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Go back, this is the moment, tonight is the night.